You are welcome to my YouTube channel. This is your teacher again, taking you through math. Now I'm going to take you through math for senior 3 or form 3, and it is a series. I'm taking you through the 13 topics of senior 3, which are going to take you through equation of a straight line, trigonometry 1, topic 3 as data collection and display, topic 4 as vectors, topic 5 ratio and proportion, topic 6 business mathematics, topic 7 trigonometry 2, topic 8 matrices, topic 9 matrix transformations, topic 10 simultaneous equations, topic 11 probability, topic 12 quadratic equations, topic 13 circle properties. Now before I start, I request that you subscribe to this YouTube channel. Please do it to encourage me moving. Now let's dive into the first topic here. The first topic is equation of a straight line, and under it we are going to look at the following: the general form of the equation of a straight line. Then we're also going to draw graphs for the equation of a straight line, then look at their relationship between the line and the drawn graph. Then we're also going to look at finding the equation of a straight line from two given points, from a number of points, from the graph. Then also we are going to look at finding the x and y intercepts. We shall also look at parallel lines. We shall also look at perpendicular lines. But remember that you visited the equation of a straight line in senior 1 in around your topic 11. So go and visit that work for senior 1 about finding the equation of a straight line. Let's dive into the first subtopic here under equations of the straight line. Let me create space for myself here. Our topic here, we are discussing equation of a straight line. Now subtopic 1 is the general form of the equation. The general form of the equation of a straight line. Now there are about two forms how we represent the equation of a straight line, but the so common form, the one that you use, is the one that we are going to speak about here. Now the equation of a straight line is given by y is equal to mx plus c, or this is not a common form, but it also represents equation of a straight line. But for the interest of this video and this learning, we are going to use y is equal to mx plus c. So in the equation y is equal to mx plus c, we can define the terms there. M stands for gradient, then stands for the y-intercept. Now what is gradient? Gradient simply refers to the steepness of a line, or the how we call it the slope of the line. If you draw a line like this, then this how it slopes is what we call the gradient. When it is much steep, this line is steeper than this, so this line has a higher gradient than this one here. Now another line can face this way. We realize that a line facing like this, we say it has a rise. This one is slanting upwards, this one is slanting downwards. This other one has a positive gradient, this one has a negative gradient. I think we notice that's the difference between those two lines. Let's give examples of such equations. We can have y is equal to negative 3x plus 4. I can also have 2y is equal to 4x minus 1. Now in this other one here, this negative 3 stands for our gradient, and being that this 3 is negative, it just means that the gradient here is negative and here the gradient is positive. So this has a y-intercept of 4. This has a y-intercept which we can calculate. Let's dive into an example here. So in each case, states the gradient and y-intercept. So we can have part A as y is equal to negative 2x plus 1. Now, before you state that, you have to compare the given equation by the general equation. We realize that this equation has our gradient as negative 2, so m is negative 2. Then the y-intercept is positive 1 here. What does the word intercept mean? Intercept means where the line cuts that axis we are talking about. To intercept is to cut into something, or to, when a line cuts into an axis, we call that place an intercept. So this is where this point 1 stands for where the line cuts the y-axis. We shall dive into that in deep details as we move through this topic. Now this is the first subtopic, the general form of the equation of a straight line. We can have several examples. Like part B, we can have 4y minus 2x is equal to 4 is equal to 7. So we first have to rearrange this equation if we are to make any decision as concerning the gradients or the y-intercept. So we rearrange that one in terms of the required equation. So we take 2 the other side to become 7 plus 2x. So divide through by 4. So we arrive at 7 out of 4 plus x out of 2. So we realize that the neighbor of x is a half here. Of course, we can further rearrange it into this. So it means our gradient will be a half and the y-intercept will be 7 out of 4. That's how we can realize the gradients and the intercepts from the general equation of a straight line. Let's now dive into drawing these straight lines here. So the next subtopic is drawing the straight lines. If you are given an equation, so let's consider an example. Draw the line. So I can have y is equal to negative 3x plus 4. So in drawing this line, we have to create in some coordinates. Of course, for any line, we only need 2 coordinates here. So we can have 0 as x. Make sure the value put here does not give a fraction. So by putting here 0, we can try to substitute in there. While we look at negative 3 times 0 plus 4, so that one will give us about 4. So here you get 4. Can try to put 1 in the place of x. So when you put 1, so when x is 1, here when x was 0, so when x is 1, y will be negative 3 times 1 gives us a positive 1 here. So this would arrive at 1. Now we encourage that when you are drawing these graphs, always use a graph paper and ensure that you are using a graph paper and a ruler. So this is just a sketch, but where you are, use a graph paper. So this is 1, 2, 3, 4. Negative, this is positive 1, 2, 3, 4, then 5. Of course, endeavor to put the arrows because these are actually number lines and number lines are endless. So this is a vertical number line. This is a vertical number line, horizontal number line. Endeavor to put the arrows respectively. So when we are plotting, we can plot 0, 4. 0, then the y value is 4, then we have 1, 1. 1, 1 is right here. So our line would actually pass through here. So we see that from our line, the gradient is negative, so the line has to slant downwards in this case. Now that's how you come up with lines. We realize that we can see the intercept from our line here. The intercept is 4. Then we can also see this gradient from this same line that we've drawn by looking at, of course, we know very well that our gradient can be taken as a rise over a run. A rise will refer to the vertical distance, then the run will refer to the horizontal distance, which we can call change in y out of change in x. Change in x. So change in y out of change in x. So the change in y, since this line slants downwards, the change in y actually we decide some 2 points on the line, then we can try to look at that distance there. So we can try to measure how many, let me assume I'm taking such a point on this line, this point, and maybe this point. So I look at the downward distance, then divided by this horizontal distance. So I will count these units, 1, 2, 3, 4, 5. Then I will count horizontal units, and I will divide these vertical units by these horizontal units. So by counting downwards, vertically the units are negative because we are going down. Then this way is a positive unit. So the final answer in the gradient will be negative. It's because of lack of an accurate graph paper. That's why the values might not be very accurate there. So we can see the gradient by calculating the rise and dividing by the run, or calculating the change in x dividing by the change in y. Let's now dive into the next subtopic of finding the equation of a straight line. Finding equation of a straight line. Straight line. Now, how do we find the equation of a straight line? There are about 3 formats that can be set under this area. We can give you a number of points and you just compare the pattern in the values of x and y. Then by observing the pattern, you can look at how x is varying vis-a-vis how y is varying. Then you can formulate the equation from that relationship. Or we can give you 2 points, and from that we can apply about 2 methods to find the equation of a straight line. Then we can also give you a graph. Then from the graph you can find the equation of a straight line. Let's jump into the first case where we give you several values and you compare the relationship between x and y. So obtaining the equation of a straight line by relating x and y. So let's assume you have been given these coordinates. You have been given 1, 1, 2, 2, 3, 3. We can see from this case that here for the value of x you have also the same value of y. So this can be written as y is equal to x. So this is the relationship between them. You can have another case as this 1, 3. Then you can also have 2, 5. You can also have 3, 7. By looking at this, we can see that for every value of x, you realize that something has happened to x, then you receive the value of y. So we can look at this as probably if we took 2x plus 1. So here you have to think out which pattern, which relationship exists between x and y. So let's test out this. This is 2 times 1, that's 1 plus 3. 2 times 1 plus 1 gives us a 3. Let's try out this. This is 2 times 2 plus 1 gives us this 5. Let's try out a 3. This is 2 times 3. The value of x are 3 plus 1. That gives us 7. So this would qualify to be the equation. But this is quite tasking and would need a lot of brain work. So we encourage that use other methods to arrive at the equation of a straight line, such as calculation or the graphical method. So let's now look at another part here, obtaining the equation of a straight line given 2 points. Now even if they give you many points, just choose any two and work with those. So I'm going to remove this, then put here an example, and I'll use two methods to handle it. Find the equation of a straight line passing through points 2, 2, -1, -1. Now right away we can find the equation of a straight line by two methods here. Of course, even there can be even more than two methods, up to 3 methods. We can use the graphical method, we can use the general form y is equal to mx plus c, then we can use the concept of gradients and equate gradients. So there are about 3 methods there, but for this interest of time, I'm going to use 2 methods. So method 1, we first find gradient. So our point is 2, 2, -1, -1, this is x1, y1, x2, y2. So our gradient m is y2 minus y1 out of x2 minus x1. So that gives us -1 minus 2 out of -1 minus 2 again. This yields us -3 out of -3, yielding us gradient as +1. Now we can call in this general equation using this equation. So using y is equal to mx plus c, our gradient is already found, so I'm going to use one of these points and find the value of the intercept. So using this equation and also this coordinate 2, 2, so I can have the y value and the x value here. So our x value is 2 and our y value is 2, so this is 2, gradient is +1 times the 2 for the x plus c, that gives us our slope, giving us our intercept that we are getting seems to be 0 here. So this is 2 for y, 2 for x, then the intercept has that. So the gradient has 1, the intercept gives us 0. So let's punch into this equation. So y is equal to m, which is 1. So this will be x plus 0. That means our equation is equal to y is equal to x. So our equation remains this. This is the first method of approaching this. We can also have the second method here, where we are going to equate gradients. So method 2, we can also first find the gradient here by subtracting our 2 given points. Can call this 1, this -1, 1. So this is x1, y1, x2, y2. So it is gradient m is equal to -1 minus 2 out of -1 minus 2. That gives you 1. So we can let another point be on the line. Let point xy be on the line. So we can call in this point and one other point. So I'll have 2, 2 with xy. So then this is x1, y1, x2, y2. So I'll go into gradient is equal to y2 minus y1 out of x2 minus x1. That will definitely give us our gradient is 1, then our y2 is y minus 2 out of x minus 2. So by simplifying this math, we arrive at y minus 2 is equal to x minus 2. Y will definitely, by calculation, subtract 2 on both sides, minus 2 plus 2 is equal to x minus 2 plus 2, yielding us y is equal to x. This is 0. 0, 0. So these are the two methods of finding the equation of a straight line. Let's immediately dive into the concept of finding. This is a point again. Another way that they can ask you to find the equation of a straight line is when they give you a graph. So on this other page, I've put for you a number of some good numbers. You work with them as you practice through this topic. So let's look at the other third way of how we can find the equation of a straight line given a graph. So obtaining equation of a straight line from the graph. Straight line from the graph. So how do you use the graph to find the equation of a straight line? Let's sketch here kind of a graph. In case they provide you with the graph, remember the knowledge of equations of straight lines is applied in very many real life situations, such as getting the relationship between distance and time, getting the relationship between the work done by workers with can look at the amount you are paying them vis-a-vis the work they are doing. So let's have a straight line created here. So we try to find its equation. So we can be tasked to get the equation of such a straight line. And how do we achieve that? So we can have this straight line passing through this point here. So this can be our first line. Then maybe I can have another line here. So I can call this A, this B. So do I find the equation for A? Here I can have equation for line B. Then here I have equation for line C, for line A. Now there are two ways here, of course. You can pick out some coordinates on the line and you use the calculation method we just discussed. So you can, if you are finding the equation of line A, you can definitely take two coordinates 0, 2 and negative 2, 0 to use them in obtaining the equation. But of course that would be a bit time consuming and mechanically expensive. So we would request that you can use this method of analyzing the graph to obtain the gradient from the graph and also the intercept. So we can realize that the intercept for line A is 2. So the y-intercept C is 2. Let's look at the gradient. Now this line has a positive gradient. You know, it is slanting upwards or it is going upwards. So we can just, if I decide this point and this point, look at this rise, can look at it from here by moving like this. This is the rise, then this is the run. So we are going to subtract, we are going to divide the rise divided by the run. So this would be the change in y out of change in x, which we call rise over run. So rise divided by the run, or can be change in y, change in y. Since you are moving upwards, it's positive, move like this, then like this, change in x. Change in x. Therefore, you'll have 2 units. You can count here 1, 2 from this axis, 2 units divided by 2 units across, so the gradient is 1. So by using this equation, you can arrive at y is equal to mx plus c. So our m is 1, so you should have x plus c, which c is 2. So this is the equation for that case. So you can also look at equation for b by looking at b slanting downward, so we expect it to have a negative gradient, but it has a positive c-intercept at 3. Let's use this other point and this other point to establish the gradient. So you look at the fall here, which is negative, subdivided by this run here. So we are going to have m as this distance measured is 1, 2, 3, negative 3 units. We're going to divide it by this 1, 2. So out of 2, that gives us negative 3 out of 2. So our y is equal to mx plus c. That definitely gives us negative 3 out of 2x plus c, which is 3. So you can use either get 2 points, 0, 0, 3 and 2, 0 to get the equation, or simply pick it by observing the graph. So let's look at the x and y intercepts. How do you get the x and y intercepts? So x and y intercepts here. So x and y intercepts. So you said the word to intercept is to cut through, or to, if you intercept your friend, you actually meet or you enter into your friend, if there is the word enter. So here we can look at the how do you get the x-intercept and the y-intercept from the given equations. Now let's notice this, that the word x-intercepts means the graph is cutting the x-axis, y-intercept meaning the graph is cutting the y-axis here. So let's dive into something here. Let's look at this line here. Find the x-intercept and y-intercept of the line 2y is equal to 4x minus 1. So let me use another format here that might be easier to handle. So you are going to have y is equal to 4x minus 1. So for simplifying the lesson, so if we are to sketch this line, we are saying that it will cut the, already we've understood what's y-intercept here, so I will not waste a lot of time to sketch this. Notice that it passed there. So if I used two coordinates, 0 and 1, so when x is 0 I get negative 1, when x is 1, so I'll get this as 3. So our coordinates is 0, negative 1 and 1, 3. So I can have that, sketch right there. So let's dive into this exploring here. It's 0, negative 1, 0, negative 1, just right here, then 1, 3. 1, 3 is right here. So if you plot that, your line definitely have a positive slope. So it's cutting x-axis somewhere here, then cutting the y-axis as negative 1. So the y-intercept first, y-intercept is actually negative 1. Then we realize that this coordinate for x-intercept is a fraction, which that means the y-intercept coordinates are 0, negative 1. So the coordinates here are 0, negative 1. That means y-intercept occurs when x is 0. That means by calculation, can use this same equation to establish that if y is equal to 4x minus 1, and if x is 0, that's where the y-intercept occurs. That means you punch in here and you get 4 times 0. That gives us about negative 1. Now if you wanted to get the x-intercept, this point here, of course it's occurring when y is 0 on this line here. So to get the x-intercept, we definitely, for x-intercept, we definitely make y 0. So by making y 0 in this equation here, we get 0 is equal to 4x minus 1, and by calculation we'll get a quarter. So this fraction of value is 0.25 or a quarter. So the coordinates for this point would actually be negative 4, 0, because the x value is I mean a quarter 0, because the x value is a quarter and the y value on this line is 0. So these axes have to be continuous. Now that's how we arrive at the intercepts for both the x and y intercept. We realize that you get the y-intercept by equating x to 0, and you get the x-intercept by making y 0. Let's now turn to parallel and perpendicular lines as our last subtopic in this topic here. So let's first start with parallel lines. But before we start parallel, let's dive into this example to understand from this example what we mean by parallel lines and perpendicular lines. So I've started with parallel lines right away there. So let me modify this equation for myself here. This is plus 3. So let's try to get the coordinates for those two lines and see how they will behave. So this is x, y. When x is 0, y 3. When x is 1, I can take x is 1 again, then I can arrive at 6 here. So this is 1 times 3 plus 3, that is 6. So let's have this other equation, y minus 3x equal to 0, which becomes y is equal to 3x. So by having x, y, if this x is 0, then definitely y is 0. If x is 1, y is about 3. Let's try to plot that and we see. This is 1, 2. Now let's try to plot this. This is 0, 3, 0, positive 3. 1, 6, 1, 6. So I need a 6 up here to cater for that. Ensure you put arrows because these are number lines, vertical number line, horizontal number line. So by putting 1, 6 about here, so that right away gives this kind of line. My blackboard is not like a graph paper, so endeavor to plot on a graph paper. It can cut where it's not supposed to cut, but the idea is to show you how the lines are looking like. So 0, 0 for this other line, then 1, 3. 1, 3 right away there. So when we sketch the two lines, we realize that they are parallel to each other, or they have equal distances of separation from each other and will never meet. So lines which have equal distances of separation and can never meet are parallel lines. So we can only observe one important thing from these two parallel lines, that if we tried to look for the steepness of this line, the slanting nature of this line is the same as the slanting nature of this line. That only means they have similar gradients. And by observation of their equations, we can see the gradient is 3, the gradient is 3. So we can comment on these lines that the lines are parallel and have equal gradients. So that's the concept of parallel lines. Let's now dive into one number here, the second number on parallel lines. So we can have number 2, find the equation of a straight line passing through point -1, 2, and it's parallel to line for x minus y is equal to 2. So from there we can first establish the gradients, keeping in mind that the gradient of two parallel lines is the same. So make y the subject. So have 4x minus y, can transfer y the other side, so it will be is equal to 2 minus y. Can transfer y the other side and 2 transfer this side, so that we can easily rearrange that. So we rearrange. It will be 4x minus 2 is equal to y. We realize now that the gradient m is 4. So we can call this gradient m1 as 4 for this second line. Then the gradient m2 is also 4 for the first line here, because parallel lines share the same gradients. Now, can use now our equation y is equal to mx plus c to establish the gradient, the y-intercept rather. So using this point negative 1, 2, punching in here y is 2 is equal to gradient is 4 times negative 1 plus c. So 2 is equal to negative 4 plus that. So our c is 6. Then our equation would be y is equal to m, which is 4. That's 4x plus c, which is 6. So that's how we come up with the equation if the lines are parallel. Let's dive into perpendicular lines. So looking at perpendicular lines here, perpendicular lines. Let's look at these two lines. Plot, draw the lines. The lines, that will be 5y is equal to 4x plus 10 and 4y plus 5x equal to 4. So we can plot them differently. So we can establish some two coordinates here. When x is 0, we arrive at y is 2. Then when you can try out the next numbers, 1 would give a fraction, 2 would give a fraction. Let's try out a 5. So we patch in a 5, we get here 6. So that is 4 times 5 is 20 plus 10 is 30 divided by 5 gives us that. So we can now look at this other line, 4y plus 5x equal to 4, xy. So by observation, this would be, if we put here 0, we will get 1. Other numbers, when you try out a 2 to give a fraction, try out 1 give a fraction, try out a 4, gives us about negative. So 5 times 4 is 20, negative 4. So we can plot that. So you try to plot that on your graph paper and see where you end. So this is 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, not negative, sorry. So you try to plot those two lines on the graph paper to avoid such errors. This is 1, 2, 3, 5, 6, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 1, negative 2, negative 3, negative 4. So try to plot that. So 0, 2, 0, 2 is right here. Then 5, 6, 5 with a 6 somewhere there. I think you remove that table. 0, 1, so 0, 0, 1, 0, 1 is right, 0, 1, up there, then 4, negative 4, 4, negative 4 is right here. So you can try to pass through these two lines. Then also looking at this, we see that those two lines are perpendicular to each other, so they are perpendicular. Now we can only notice two things. If we try to find the fall in this line and the rise in this line by finding the two gradients either graphically or by using the equations, we can only notice one thing. Let's try to find the gradient for this by rearranging this. So 5y is equal to 4x plus 10 out of 5 out of 5. So y is equal to 4x out of 5 plus 2. Let's type in this. 4y is equal to 4 minus 5x. So out of 4, y is equal to 1 minus 5x out of 4. So our m2, negative 5 out of 4, our m1 is equal to 4 out of 5. So you can notice that if you multiply these two gradients, you'll always get negative 1. So let's multiply this. So you get 4 out of 5 times negative 5 out of 4. So the gradient of two perpendicular lines is always equal to, the product of their gradients is always equal to negative 1. Let's do one number here. then we see where we can arrive. Hope you understand that very, very clearly. So our question says find the equation of a straight line passing through points -1, 2, and is perpendicular to the line x minus 4y equal to 1. So let's first rearrange this equation to get the gradient. So let's try to rearrange that first. So rearranging that equation, make y the subject. So x minus 4y is equal to 1. Let's bring 1 this side. X minus 1, its positive turns to a negative, then this turns into a positive. So divide through by 4. So we arrive at y is equal to x out of 4 minus 1. So let's try to find the gradient. The gradient m1 is now a quarter the neighbor of x, or the coefficient of x. But for perpendicular lines, the second gradient for this other line is what we want, or you can call it m2 or m1. So m1 times m2 -1, or the m2 I want is rather -1 out of m2. I can divide direct, or I can solve in any way. So I will have a quarter times m2 is equal to -1, multiply through by 4, so I'll get m2 as -4. So again, punching into this other equation, y is equal to mx plus c, using this same coordinate, so you get this as x and that as y. So this is 2 is equal to our gradient m2 is -4. So -4 times the x value, which is -1 plus c. So this is 2 is equal to positive 4 plus c. So c will be equal to 2 minus 4, giving us -2. So that's how we get the intercept. Then coming back to our equation, shall get y is equal to m, which is -4x minus or plus the negative intercept c. So this is our final equation for the required line. So thank you for watching this YouTube video. Do this exercise. You can send me a comment in the description. Let's meet again. Remember to subscribe to get math explained clearly. Bye.